Dear students, in the today's video session, we are going to discuss about the relative strength of carboxylic acids. Carboxylic acids are containing COOH group in them as a functional group, where it has got a replaceable hydrogen. We know based on the Arrhenius concept what are all the substances which are giving hydrogen plus in their solution are called acids. So here are the carboxylic acids or COOH. It is the formula for carboxylic acid that on partial dissociation we can have RC double bond O minus and then H plus. So it is giving out the hydrogen plus and hence it is behaving like an acid. It is an anion called carboxylate anion. So the hydrogen plus is subtype and its counterpart, the conjugate base, must be a stable species. If it is stable, we can surely say the hydrogen plus will be stable. And how do you say this carboxylate is stabilized? It is explained by the resonance stabilization of carboxylate anion. So this is the way to understand. RC double bond O minus. When the pair of electron is migrating here, the bond breaks up in between the carbon and oxygen, so that we can have a resonance structure as follows. Once the pair of electron is moving here, the bond breaks up so that we can get the original structure. So these are the two resonance structures which are responsible for the stabilization of this carboxylate anion. And hence this carboxylate is more stable and the substance is behaving like an acid. Is it clear? And for any acid, when the Ka value is greater, we can surely say the acid is a stronger acid. So Ka is a parameter, dissociation constant of weaker acid, that decides whether the acid is stronger or weaker. How to calculate the Ka? This is a way by which we can calculate. RC double bond O minus and H plus. This is the carboxylic acid that is dissociated to form RCOO minus and then H plus. And we are going to calculate the Ka, dissociation constant Ka, that is equal to the product of these two, RCOO minus and then H plus. The square bracket says that the active mass, the molar concentration of carboxylate anion and hydrogen plus, divided by the molar mass or the concentration of RCOOH undissociated. Suppose if it is poorly dissociated, undissociated molecules are greater in their concentration. Ultimately, Ka would be lesser. So Ka is deciding whether the acid is weaker or stronger. I repeat, when the undissociated molecules are maximum, if it is poorly dissociated, we can say it's a weaker acid. Once if it is poorly dissociated, the concentration of this molecule will be greater. When the denominator increases, Ka will be lesser. So for your weaker acid, Ka value is lesser. Try to understand. Suppose the acid is completely dissociated. Majority of the molecules are dissociated. We can have the greater concentration of carboxylate and H plus. So as a result of that, we can have Ka value is greater and it would be applicable for a stronger acid. So for a stronger acid, Ka is greater and for a weaker acid, Ka is lesser. In this way, Ka is deciding the strength of acid. And we can say that the carboxylic acids are having lesser Ka value. Ka is lesser and their pKa is greater. What do you mean by pKa? pKa is nothing but minus log of Ka. If you take the negative logarithm for Ka, that will be giving you the pKa. The carboxylic acids are weaker in their nature, and due to that they may have greater pKa on comparing with the mineral acids. Okay, and we can try to compare the relative strength of various carboxylic acids. I am writing certain examples here. You see this one, if I write HC double bond OOH, CH3C double bond OOH, CH3 CH2C double bond OOH. Among all the three substances, which will be the stronger acid and why? If you take this compound, propionic acid, its IUPAC name is Propionic Acid, where the group, ethyl group is electron releasing group. So that is releasing electron towards the carbon atom, and carbon can release electron towards the oxygen. Oxygen is pushing electron towards the hydrogen. So that the bond in between oxygen and hydrogen will become a stronger bond. Due to this strength of the bond, the hydrogen cannot be easily replaced. So here we can say the acidic strength decreases. It is falling down. Say the formic acid. There is no electron releasing group. So most probably here, oxygen will get the pair of electron in between oxygen and hydrogen because of its greater electronegativity. Due to that, the oxygen carries minus and the hydrogen is carrying plus. So this hydrogen is easily replaceable as there is no electron releasing group in the case of formic acid. And this electron releasing group is responsible for plus inductive effect. So whenever plus inductive effect increases, the acidic strength decreases. So we can say these two are inversely proportional to each other. Greater the acidic strength means lesser the plus inductive effect. Lesser the acidic strength, weaker the strength of acid, greater would be the plus inductive effect. So in the case of propionic acid, the inductive effect is greater due to the presence of this ethyl group, electron releasing group. And because of that, this should be the right order of acidic strength. Formic acid is little stronger than the acetic acid. Acetic acid is stronger than the propionic acid. Because on comparing ethyl and methyl, ethyl might be the best electron releasing group rather than the methyl, and hence propionic acid is weaker and this acetic acid is slightly stronger on comparison, and formic acid is more stronger on comparing those two substances. And from this we can conclude, when the plus inductive effect increases, acidic strength decreases, They are inversely proportional to each other. Try to understand. This group is releasing electron towards the carbon. Carbon releases electron towards the oxygen. Oxygen is pushing electron towards the hydrogen. So the bond becomes stronger, which means this hydrogen cannot be easily replaced. Ultimately, acidic strength decreases. Is it clear? Yes. I am writing the acetic acid CH3COOH, and this is the monochloro acetic acid, and this is the dichloro acetic acid, and this is the trichloroacetic acid. So 4 acids are written here. The compound's name is acetic acid. This is monochloroacetic acid, and this is dichloroacetic acid, and this will be trichloroacetic acid. Yes, we are going to compare the acidic strength of all the 4 substances. First, you see the last case, trichloroacetic acid, in which it has got 3 chlorine atoms. I am extending an arrow like this. The arrow denotes that Cl is an electron withdrawing group. So once when you find electron withdrawing group, the carbon will get electron from the nearby carbon, because electron deficiency arises out on this particular carbon. So this carbon is trying to get electron from this carbon atom, and this carbon atom is getting electron from the oxygen, and oxygen is trying to get the electron from the hydrogen. Due to that, the bond in between oxygen and hydrogen becomes weaker bond, and the hydrogen is easily replaceable. We can say hydrogen can be replaced as H+. So we can say that its acidic strength increases. Previously, you have studied that when you find electron releasing group plus inductive effect, that leads to decrease in acidic strength. But in the present case, the Cl is withdrawing electron. Due to that, minus I effect increases. So once the minus I effect increases, acidic strength increases. So from this we can say acidic strength is directly proportional to minus inductive effect. See, the dichloroacetic acid, it has got only 2 electron releasing group. Here the electron withdrawing groups are 3. But it has got only 2 electron withdrawing groups. It's not electron releasing, it is electron withdrawing. There are 2 electron withdrawing groups. So that will be demand of electron on the carbon. The carbon gets electron from the nearby carbon. This carbon is getting electron from this. As a result of that, the strength of bonding between oxygen and hydrogen decreases. But on comparing these two, it has got maximum electron deficiency, but this is having lesser electron deficiency due to the presence of only 2 electron withdrawing groups. See the monochloroacetic acid, it is also containing one of the electron releasing group. So there will be demand of electron. The carbon gets electron from this and oxygen is giving electron to the carbon atom, and this bond is becoming weaker. Among all the three, it would be the strongest due to the presence of 3 chlorine atom. It has got only 2 and it has got only 1 electron withdrawing group. But in the acetic acid, there is no electron withdrawing group. And due to that, it would be the weakest acid, and the monochloric acetic acid is stronger, dichloroacetic acid is more stronger, and this is most strongest trichloroacetic acid because it has got 3 electron withdrawing groups. So it's an interesting comparison. The acidic strength increases with minus inductive effect. Which is responsible for this minus inductive effect? Electron withdrawing group, namely chlorine atom. Okay, based on the same idea, we can have one more comparison. This is the other comparison. All are substituted carboxylic acids. See, this is the fluoro substituted acid, so that I can call this as fluoroacetic acid. And see this one, it is to be called chloroacetic acid. And here it is to be called bromoacetic acid. And here it is called iodoacetic acid. And which will decide the strength of acid? We know among the halogens from the top to bottom, fluorine, chlorine, bromine, iodine, from top to bottom, electronegativity value decreases. So which would be stronger electron withdrawing group? Fluorine. So it has got a better tendency to receive electron from the nearby carbon, and this carbon is getting electron from this, and oxygen is releasing electron towards the carbon, and this bond is becoming weaker bond, and hence this hydrogen is easily replaceable due to its greater electronegativity of fluorine atom. Here the chlorine is also electronegative, but on comparing with fluorine it is lesser electronegative. So its electron withdrawing power decreases, and hence acidic strength decreases. On comparing chlorine and bromine, bromine is having still lesser electronegativity, so acidic strength falling down. Iodine, it has got the least electronegativity, and hence it has got least or lesser electron withdrawing power, and hence iodo-substituted acid is weaker. So this is also an interesting comparison. Here also the same is explained, which is explained acidic strength is directly proportional to minus inductive effect. Where will you find greater minus inductive effect? In the case of fluoro substituted acid, and hence it is more stronger than any other substituted acids. Okay, apart from this, we have got another simple comparison. Yes, this is the comparison. We can have nitro group, cyano group, fluoro, chloro, bromoiodo. Among all the things, it has got a powerful electron withdrawing power. Electron withdrawing power of nitro group would be greater. So if it is substituted in any carboxylic acid, for example, if I write one of the NO2 group in the case of acetic acid, nitro substituted acetic acid, the strongest electron withdrawing group is available. And when you have such kind of NO2, it would be the strongest acid rather than the other substitutions. So nitro substituted acid is more stronger than the cyano substituted, and cyano substituted is more stronger than fluoro substituted. Fluoro is more stronger than chloro substituted, and chloro is more stronger than bromo substituted acids. Among all the things, iodo substituted acid will be weaker acid due to lesser electronegativity of iodine. So as a whole, among the carboxylic acids, and when it is compared with other organic compounds, we can have an order RCOOH is more stronger than the phenol. Phenol is more stronger than water. Water is more stronger than alcohol. Alcohol is more stronger acid on comparing with the last category of C triple bond N. Otherwise, we can say carboxylic acids are more stronger than phenol. Phenol is more stronger than water. Water would be more stronger than alcohol. Regarding its acidic strength. Okay. Even when you have alkyne like this hydrogen is not an easily replaceable hydrogen. So it has got the least acidic strength among all the substances. Any organic compound having the replaceable hydrogen is acid. So the order may be given as follows. Carboxylic acid first, phenol next, water, alcohol, and alkynes. So it is an explanation, and based on this explanation, we can come to the conclusion that these are the points which are consolidated finally regarding the carboxylic acid strength. The point 1, acidic strength is inversely proportional to plus inductive effect, and acidic strength is directly proportional to minus inductive effect. The groups responsible for plus inductive effect are alkyl groups CH3, CH2, CH3, etc. And the groups responsible for minus inductive effect NO2, CN, F, Cl, Br, and I, etc. So these are all very important messages related with the acidic strength. And based on these two, we can say the acidic strength decreases in this order. And moreover, on various organic compounds, this is the strongest and this will be the weakest acid. So this is about the relative strength of carboxylic acids. So you can continuously observe this video. Suppose in the first attempt, if it is not clear, again you go through so that you might be getting clear idea about acidic strength. Thanks for watching. Thank you.